Hello, everyone. My name is Önder Kalıcı, and I'm a principal software engineer at Microsoft, working on PostgreSQL and specifically on Citus. So today I will be talking about foundations of distributed PostgreSQL with Citus. The first question is, what is Citus? Citus is a PostgreSQL extension that transforms PostgreSQL into a multi-node distributed database. From the application's perspective, it is just a PostgreSQL. Behind the covers, Citus hooks into several points in the query processing and can change how the database behaves. And because from the application's perspective, Citus is just PostgreSQL, Citus can be used with all the tooling and all the ecosystem of PostgreSQL. And again, because Citus is an extension, it is up to date with all the new PostgreSQL innovations. As soon as a new PostgreSQL version comes, Citus is ready for running with that version. And then if you are not very familiar with Citus, Citus is an open source project that you can find all the source code on GitHub. So then the second logical question is, what is an extension? Like, what does it mean to be an extension to a database? So from Postgres perspective, an extension consists of two set of things. The first thing is any SQL object, like it could be a table, type, function, whatever you name it in a database. And then the second piece is some shared library that can be loaded into Postgres. So on the left-hand side, you see the object, for example, that Citus creates. So there are some tables, some functions, and some other things, but so you can have any SQL object. And then on the right-hand side, you see the C code that actually runs in the shared library and loaded into the Postgres when these functions are called. And this is how Postgres makes extensions work. So PostgreSQL allows extensions to change, to extend, to override how the database behaves. And there are several APIs that enables extensions to do that. For example, as we talked in the previous slide, an extension can define some SQL callable functions. So an extension provides some SQL, and then users can call this in the SQL command line. I think probably the more important parts are planner and executor hooks. So PostgreSQL allows extensions to override how the planning and execution is done on the database. And as being a transactional database, PostgreSQL also allows extensions to override, to extend what happens during the transactions. And like, especially in the critical points of the transactions, like just before the commit or just right after the commit. So when a user comes in and executes a query on the Citus database, Citus just behaves as if it's a Postgres, gets the query from the user's perspective, but under the covers, what Citus does is gets this query and decides where the shards are for this query in the cluster, and then runs these queries across the cluster in parallel. And these queries are the queries that are sent to the shards are just regular PostgreSQL queries, and the shards are regular PostgreSQL tables. And then from the application perspective, it's just talking to the Postgres database and getting the results back. And as part of being a distributed relational database, Citus also handles distributed transactions. So there are roughly two classes of transactions. The first class of transaction are transactions that touches only a single node in the cluster. For such transactions, Citus delegates the transaction to the worker node where this transaction is running. So basically, Citus's job is to delegate the transaction to the worker node and let the heavy lifting done by Postgres. When there are multiple nodes involved in a distributed transaction, then Citus's involvement becomes a little bit more. So PostgreSQL provides some hooks, as I mentioned earlier in this presentation. So And then Citus uses Postgres's another infrastructure, which is called two-phase commit, while handling this multi-node transactions. So just before the commit happens, PostgreSQL lets Citus know about that. And then at that point, Citus sends prepared transactions to the remote nodes. Prepared meaning that it is ready to be committed. And once every transaction on multiple nodes are prepared, right after the commit happens on the coordinator, PostgreSQL again gives control to the extensions where Citus goes and commits the prepared transactions. So this is how Citus integrates with the distributed transaction management. And then in this last slide, I also want to talk about Citus 11, like what is the current state of Citus and one important feature of Citus. So in this presentation, I implicitly talk about a coordinator node. So as of Citus 11, which happened around 6 months ago, Citus supports querying from any node. Now you can connect to any node in the cluster and do select, insert, update, delete commands. But certain commands, the DDL commands like alter table, create index, or create table type of commands should still go through the coordinator. And then just to give some more context on this, a single coordinator is already capable of handling very high number of transactions and very high throughput transactions. But then there are some very demanding applications where a single coordinator might become a bottleneck. And more commonly, some users and some prospective Citus users used to see the single coordinator as a potential scalability bottleneck for the future. Although Citus Coordinator can handle very high number of transactions, users wanted to have the flexibility to have even higher throughput. And then as of Citus 11, with the query from any node, Citus can scale to really high number of transactions with very high number of writes, like in total per very high number of writes per second. And then under the hood, how this happens is that the Citus Coordinator holds some metadata and the schema of the cluster. The schema involves like tables, views, functions, whatever you use in querying the database. And this metadata and schema is now synced to all nodes, which enables querying the database from any node. So this is end of my presentation. Thanks for listening.